Welcome. My name is Marco Coisson and I'm a researcher at the Italian National Meteorological Institute. With this video, I want to show you how we calibrate a magnetic probe in the field range within 50 millitesla and 1 Tesla. To do such a task, we need an electromagnet with large poles and flat poles, because we want to be sure that the volume in which the magnetic field is homogeneous is sufficiently large. For our magnet, the size of the volume of homogeneity is approximately 10 centimeters. The calibration is done by comparing the unknown probe that we want to calibrate with a reference probe that is based on the nuclear magnetic resonance effect. The unknown probe is this one and is placed in the middle of the gap of the magnet where the field is homogeneous. The same for the reference probe, the nuclear magnetic resonance one, which is placed on this direction, again in the middle of the gap. Both are transverse probes, so they are sensitive along the direction of the applied magnetic field. The nuclear magnetic resonance measurement is indeed a frequency measurement. So our reference for the magnetic field is a frequency meter, especially conceived for doing such kind of measurements. The physical principle behind this process is that when you apply a magnetic field, you induce the precession of the magnetic moment of the protons in water, and in the reference probe there is water inside. So you apply a magnetic field, and with a frequency meter you measure the precession frequency of the proton. Since this precession frequency is proportional to the applied magnetic field, you can directly link the applied magnetic field value to the frequency. Frequency is the quantity of the SI that can be best measured, and so it is a good means of tracing the unit of magnetic field to fundamental standard of the SI. The calibration is done by comparing the reference probe with the unknown probe and a certain number of applied field values. Now my colleague is powering on the magnet in order to reach a magnetic field that is of approximately 500 millitesla. He will use the Gauss meter to be calibrated as a rough guide for reaching the correct field value. Once the field is reached and is stable, the NMR instrument, our reference instrument, will match the precession frequency of the proton and will give us the reference value for the magnetic field, so we can compare the reading of the unknown instrument with the exact value given us by the MRI instrument. In order to do the calibration, we repeat the measurement procedure for a certain number of times. For example, here we have selected 5 different applied field values. We also have repeated for each applied field value the measurement 2 times by removing both probes and putting them back in the magnet in order to take into account possible fluctuations in the positioning of the probes. For each field value, then, we have the reading of the nuclear magnetic resonance instrument with the associated uncertainty. Then we have the reading of the unknown probe with the associated reading uncertainty, and then we combine the uncertainties so that we come up with the final field value with the associated extended uncertainty and the discrepancy between the reference value and the measured value by the unknown.